Our last example in 5.4 day 1 is just to give you a little bit of exposure to what we have as the half angle identities. Like I've mentioned before, you should only use the half angle identities when it says so in the instructions. So since the instructions here actually say it, we'll use it. What we're going to do with this is our goal is going to be to evaluate trig functions of unfriendly angles using the half angle formulas. Now I say unfriendly because they're not angles like pi over 4, pi over 3, that kind of thing. So we're going to use our knowledge of what our special angles that we know and kind of use that with the half angle identity and see if we can find out cosine of pi over 8. Now, in case you want to just do this in case you would rather work with degrees, it's okay to convert that to a degree measure. And if you do, you would find that this is 22.5 degrees. And that might help you figure out how it relates to like 30, 45, or 60 a little bit better. In fact, the angle here is called a half angle identity, and so what we want to do with this is we want to figure out the angle that's presented right here, this pi over 8, that is half of what angle? Or 22.5 is half of what angle? That's kind of the first problem that we have to figure out here and replace that in this for what's here in the cosine, because if you'll notice down here, we got the half angle identities, and it's always something divided by 2 on each one of those, and then you can plug it into these formulas. Well, in this case, the thing that's being divided by 2, if we're talking 22.5, we could say 45 divided by 2, but I want to keep it in terms of radians, so I'm going to say pi over 4 divided by 2. Pi over 4 is a friendly angle. That is our 45 degree angle, and again, that is true because pi over 8 times 2 is equal to pi over 4. And so that's why this is a half angle. We went the other direction here, and now we found this one as pi over 4. So if you look at the formula down here, what that means is that pi over 4 is u. So that's our u in this case. So when we plug that in, let's use it with the different pieces that you see for the u. So I'm going to plug that in, and we get then the square root of 1 minus cosine of u. U in this case is pi over 4. All of that divided by 2. All right, so now that's our setup. One thing you might notice as I'm doing this, you might notice that there's a plus minus in the beginning there. And a lot of times what we've done is with plus minus you have to consider both options. But it's only going to be one or the other in this case, and I will tell you about that towards the end, how we know which one it is. Let's just work through the details of simplifying before that. So the next piece of this, and the next step would be just to start simplifying what we have here. And so we've got square root of 1 minus cosine of pi over 4. If we use a 45, 90 triangle, we'd find that that is the same as square root of 2 over 2. And so now we're going to take all these things and simplify them a little bit more. Now, if you want to combine these fractions, we've got to have common denominator, so we'll do a denominator of 2. So we'll say 2 over 2 minus the square root of 2 over 2 on the inside, all that divided by 2. Then, let's simplify what's in there. So then that's going to be 2 minus the square root of 2 over 2, all of that over 2. And then we can go even further with that. If you divide by 2, which is the same thing as 2 over 1, if you're dividing by that, then it's like multiplying by the reciprocal. Oops, I'll put it a little bit farther down here. So then we have 2 minus square root of 2 over 2 times 1/2 is really what's happening here. And when you do that, I know there's a lot of steps, but when you do that, you get 2 minus square root of 2 over 4. We're getting a lot closer now. once we have this, remember that with a square root on a fraction, you can split it up into top and bottom. And so that's the same thing as square root of 2 minus square root of 2 over square root of 4, which finally we can finish it out and say, well, the top is going to have to stay as it is, 2 minus square root of 2 inside the square root, but then square root of 4 is 2. So it pretty much all comes down to 2's in this problem. Now, I did tell you at the beginning that we would have to think about, is it positive or negative? Well, here's where this value comes into play. If we want to say here, we're thinking about sine of 22.5, we want to think about what quadrant that's in. Now that's in quadrant 1, 22.5 degrees. So in quadrant 1, we'd have to just decide, all right, is cosine going to be positive or is it going to be negative? Well, since cosine is, or since any of them are always positive in quadrant 1, then we can just retroactively say, oh, these are all the positive version. I'm just going to put the plus in here to emphasize that that's the one it is. You certainly won't have to put the plus in there if you're just doing this problem on your own, but that emphasizes it. And this is what we want as far as an exact answer. You might go check it on your calculator and just punch it in, cosine of pi over 8, and see if that is the same decimal equivalent as this one.